Understanding soil liquefaction, the hidden danger of earthquakes. Hey everyone, today we're diving into a fascinating and important topic in earth science, soil liquefaction. Ever wondered how earthquakes can turn solid ground into something like quicksand? Let's break it down. Soil liquefaction happens when saturated, loose sandy soil temporarily loses its strength and behaves like a liquid. Imagine shaking a jar of wet sand. After a while, the sand starts to flow instead of staying solid. This transformation can cause buildings, roads, and other structures to sink, tilt, or even collapse during an earthquake. For liquefaction to occur, two main conditions must be met. Loose, sandy soil near the surface. The ground needs to have layers of sandy soil that aren't tightly packed. Saturated with water. These sandy layers must be soaked with water, meaning the spaces between the sand grains are filled with water. When an earthquake strikes, the shaking increases the water pressure between the sand grains. Since water can't easily compress, the sand particles lose contact and the soil starts to behave like a liquid. This can lead to ground movement and structural damage. When liquefaction occurs, several problems can arise. Ground sinking and cracks. Buildings may tilt, sink, or develop cracks. Pipeline failures. Underground pipes for water, gas, or sewage can float to the surface or break. Infrastructure collapse. Roads, bridges, and other structures can suffer significant damage. Liquefaction isn't limited to one part of the world. Here are a few notable examples. 1995 Kobe earthquake, Japan. Liquefaction caused extensive damage to buildings and infrastructure. 2010 Haiti earthquake. Severe liquefaction contributed to widespread devastation in Port-au-Prince. 2008 Sichuan earthquake. China liquefaction led to tragic collapses of buildings and highways. Preventing liquefaction involves strengthening the soil to withstand shaking. Here are some common methods. Soil replacement, replacing loose sandy soil with more stable materials like gravel or clay. This is effective but can be expensive. Drainage improvement, lowering the water level in the soil by installing drainage systems. This reduces the water pressure and makes liquefaction less likely. Soil compaction, compressing the sandy soil to make it denser and less prone to liquefaction. Techniques like vibrating machinery are used for this. Reinforcing with columns, installing solid columns deep into the ground to provide additional support and prevent the soil from liquefying. Certain terrains are more vulnerable to liquefaction, especially where high water tables, areas where the groundwater is close to the surface, like riverbanks, wetlands, and coastal regions. Regions with loose, sandy soil that's easily shaken by earthquakes. New Orleans, USA, built on soft, water-saturated soils, making it highly susceptible. Jakarta, Indonesia, rapid urbanization on unstable, waterlogged land increases liquefaction risks. San Francisco Bay Area, USA, parts of the bay are prone to liquefaction due to their soil composition and water levels. Soil liquefaction is a critical hazard during earthquakes that can lead to significant damage and loss. By understanding the conditions that cause it and implementing effective prevention measures, we can build safer communities around the world. Next time you hear about an earthquake, you'll know a bit more about the hidden dangers beneath our feet. Thank you for exploring the powerful forces of nature with us today. May your curiosity continue to drive you to understand and respect the incredible dynamics of our planet. Stay informed, stay prepared, and keep wondering about our amazing planet.